Almost every automaker and technology company that's working on self-driving cars is relying on LiDAR technology. However, Tesla decided long ago to steer away from using LiDAR, and Elon Musk has even called it a crutch for those relying on it. Yet a small handful of other players have slowly begun to follow Tesla's suit. Anthony Levandowski, who is a bit controversial because he was an all-star employee at Google's self-driving division Waymo, but left the company to found Otto, which was bought by Uber, and then was forced to leave the company because of confidentiality with Waymo. However, he then started a private company called Pronto for self-driving, which doesn't rely on LiDAR. He says that Elon Musk is right, and he believes that LiDAR is also going to be a crutch for automakers. And he also says that the problem isn't better lasers, it's better software prediction. And it seems like that's very in line with what Tesla has been working on as well. Nissan has also announced that it's holding back on LiDAR for now, but all the other car companies and tech companies working on self-driving are still pushing ahead with LiDAR technologies. Yet, Tesla has decided to drop LiDAR. So we're going to see why this is the case by starting with what is LiDAR and how does it work, the advantages and disadvantages of LiDAR, and why SpaceX, Elon Musk's other space company, chose to use LiDAR but Tesla didn't. Elon Musk says that LiDAR is a crutch for self-driving. However, he spearheaded the LiDAR project for SpaceX, so let's find out why. But first, please subscribe to our YouTube channel. We would really appreciate your support in helping us grow our channel. Also, have a look at the description below for some additional information about this video. So originally, LiDAR was a play on the word light and radar. However, now it has become an acronym for light detection and ranging. So let's go into a little bit more detail on how a LiDAR system actually works. So as you can see in this simple chart, the LiDAR system fires a pulse of light, which you see by the dark blue line here, and then the light gets reflected some short time later and travels back to the source at the speed of light, which is 300 million meters per second. So the pulse is coming back pretty fast. To travel 100 meters, it takes 333 nanoseconds. And then you get back the reflection, which is the dotted line over here. You might even get back multiple reflections if the laser went through an object or bounced off multiple objects at different depths, sort of like branches in a tree, for example. To calculate the distance, we use the velocity of the laser signal and the time it took for it to reach the obstacle and come back. So in this case, the light is traveling at the speed of light, which is c, and we multiply it by t, which is the time it took for the entire trip to hit the object and come back. And we divide it by 2 because the pulse needed to travel all the way to the object and all the way back. So we just want the one-way distance. To go into a little bit more detail, the way the LiDAR system works is that there's a spinning mirror that spins very quickly in the horizontal direction. At the same time, there's a motor that moves up and down that could change the angle of the mirror so that you can get the laser beam to point in the upwards and the downward direction. A laser pulse is fired at a fixed mirror which bounces off the spinning mirror, hits the object, which in this case is a tree, and then bounces back, in this case as the orange lines, even though the color of the light doesn't actually change. This is just for the descriptive purposes only. And then hits a photodetector, which measures the pulse and the time it took for it to reach the photodetector. It then passes all this information to the computer, which can use a point cloud to create a three-dimensional map. It can then produce a three-dimensional image of its surroundings. And here we have the three-dimensional tree that it produced. And you'll notice that it's a different color because the light that comes back from the laser is the same color as the laser. And so LiDAR doesn't get the features of the color features of the original object. So the color seen on the final image is actually just a computer generated color and not the original object's color. So if you do this in thousands of different spots, you get a point cloud. The laser system with spinning mirrors can send out 20,000 laser pulses per second. And using the specialized point cloud algorithms, it can automatically merge multiple scans into a seamless point cloud as seen here. However, is this really necessary for all applications? Would it work for self-driving, for example? When you drive, you don't know the exact distances of every single object around you, yet you are still able to figure out how to drive. So let's look at some pros and cons of this LiDAR technology. There are some big advantages to LiDAR, however, some very big drawbacks as well. In terms of pros, LiDAR has very high accuracy. It's using beams of light to calculate distance, which is extremely precise. You can get centimeter or even millimeter accuracy with LiDAR. LiDAR is also very long range. Some implementations can get distances up to a few kilometers, and that's again because LiDAR is generating its own light using a laser. The LiDAR system is high density because you can fire thousands and tens of thousands of light beams in order to build a three-dimensional map, which is very useful as each point on the map shows the distance away from you or the vehicle in this case. LiDAR also works at night because it's emitting and generating its own light waves. The frequencies of light used are also safe for the eye. You can actually look at LiDAR and it won't damage your eye. LiDAR is also very fast. I mean, it's using light, and that's certainly faster than sonar, for example, which is using sound. And it also works quite well in regular weather conditions. Now, one of the main problems with LiDAR is that it's extremely expensive. It could cost tens of thousands of dollars for a single LiDAR unit. Velodyne, one of the makers of LiDAR, apparently has a unit that's around $4,000 after they cut the price. However, most implementations can be upwards of $20,000, even $60,000 for a single LiDAR unit. So if you think about that, putting that on a car, an extra sensor, which has extra costs, and adding $4,000 to a car, or $10,000 or $20,000 to a single car is a huge amount of money that really lowers the competitive pricing of trying to sell a car. The other thing with LiDAR is that it generates enormous data sets which require a high level of analysis, huge processing power, and it could take a lot of time to analyze all of this data, so that may slow down development time. Another main disadvantage is that the LiDAR beams are still blocked by anything a camera would also be blocked by as well. For example, rain, snow, clouds, extreme reflections from the sun could also throw it off, and also reflecting off water could impact the way that the light reflects. So it is very similar to a camera in that sense. LiDAR also has moving parts, as we saw. The different motors and the mirrors that are spinning are a problem because spinning and moving things tend to break more often. Usually if you have solid state parts, the way cameras are designed, they tend to last longer and be more robust. The implementation of LiDAR that most car companies are using is also fairly ugly. It has to sit on the roof and spin, and it can't be blocked by anything. However, there are companies working on solid state solutions for LiDAR, but that would be super expensive to buy 8 LiDARs perhaps to cover all of the sides of the car. And again, another advantage of just having the cameras is that the cameras sit behind the windshield in the Tesla, and thus are sitting behind the windshield wipers. The radar in the Tesla goes through most weather conditions, and the side cameras are slightly sheltered. Forward-facing LiDAR, however, would have to sit behind some sort of glass or wipers in order to function properly in bad weather. And so is that a little bit redundant? What about the other sensors like the camera and the radar? What do these have to offer if you already have them, and what benefit does adding LiDAR have? The camera, for starters, shows a lot more detail, more information. It shows the color of objects around it, and cameras are extremely cheap, especially compared to LiDAR. Now, cameras and LiDARs are also blocked by rain and snow, so that's a problem for both devices. However, LiDAR generates its own light and cameras do not. But that said, cars have headlights and streetlights, which seem to work quite well, which is why you can currently drive at night. And also, LiDAR gives the 3-dimensional distance to each point on an object, which of course cameras can't do this. Many cars, including Tesla, have radar, which is radio detection and ranging, very similar to LiDAR. However, the main difference between LiDAR and radar is that they use different signals to detect objects. They use a different part of the electromagnetic spectrum, which also moves at the speed of light, of course. However, radar can easily operate in cloudy and rainy weather conditions and at night, as it goes through a lot of small objects. This can, however, be a disadvantage for radar. The different wavelength doesn't allow it to detect small objects, and radar can't provide the user with a precise image of an object because of the different wavelength, and it also passes through many small objects as well, so it has advantages and disadvantages. Radar, however, can tell you the distance it is away from an object, so it's similar to LiDAR in that sense. So when you already have cameras and radar, LiDAR doesn't really add that much more value. Actually, the Venn diagram looks a little bit more like this. Cameras have a little bit more information in each picture, such as color, for example, and radar can tell you the distances. So Tesla has even stated in its autonomy day that they train their neural nets with the radar distances, the distances coming back from the radar, and try to match it up with the camera footage so that over time, the AI can learn the distances of each object. Now, the radar in Teslas is only forward-facing, so Tesla can only do that moving forward. However, the car is moving forward most of the time. And LiDAR will give you a 360-degree view, however, that might not be too necessary with the forward-facing radar and cameras. The other thing that's not really shown here is the ultrasonics that are in every Tesla. Teslas are fitted with ultrasonics all around the car, and those are basically proximity sensors and can detect distance away from other objects and prevent the car from hitting things next to it. However, those sensors are shorter range. So if you already have all of these other sensors, LiDAR doesn't seem to be that important. It's simply redundant, as long as you have good software that can make use of the camera plus the radar plus the ultrasonics. During Tesla's Autonomy Day event, Elon Musk gained a lot of credibility when he said that he spearheaded the decision and the project to build a LiDAR system for SpaceX. In September 2009, SpaceX had demonstrated a proximity sensor called DragonEye, and DragonEye uses a LiDAR system to provide 3D images based on the amount of time it takes for a single laser pulse from the sensor to reach the target and bounce back, and it provided the range and bearing information from the Dragon spacecraft to the International Space Station. And the DragonEye LiDAR device was used for guiding the Dragon spacecraft as it approached the International Space Station. It's also amazing that the DragonEye LiDAR project was developed in just 10 months from the original concept to the final hardware. Some of the reasons why LiDAR made sense for SpaceX is that SpaceX didn't have machine learning, they didn't have enough data, and there were no fleet of spaceships in order to train this spaceship. Machine learning would also be totally overkill for this fairly specific application, which can be easily solved with LiDAR. It also only took 10 months to develop this solution, and machine learning would have been, again, crazy overkill and would have taken much longer with almost no data in order to train the ship to use machine learning. Also in space, there's very poor lighting conditions, and LiDAR is great for that because it generates its own light. It's definitely better than having car headlights in space. And of course, this needed to be extremely precise in order to connect the Dragon with the space station. Also, adding a few $1,000 or $10,000 or even more for a LiDAR device isn't that much in the grand scheme of the entire cost of a multi-million-dollar rocket ship. So LiDAR made a lot of sense for SpaceX in this case. Elon Musk, however, is strongly opposed to LiDAR for vehicles and calls it a crutch. The application seems quite similar to the SpaceX application, providing guidance for a vehicle. However, in Tesla's case, the vehicle is being mass-produced, and the goal is to get the cost down as much as they can to make it affordable. SpaceX isn't really going for affordability at this point. So adding thousands of dollars or tens of thousands of dollars to the price of a car has a huge impact on demand. Also, the aesthetics of the car is extremely important for Tesla in order to sell more vehicles. It looks pretty ugly to have a LiDAR device on the roof, and the 360-degree spinning version has to be there to get the full 360-degree view. Otherwise, you need some sort of solid-state LiDAR around the car, which currently doesn't really exist and would be way more expensive. The other advantage of the way Tesla is positioned is that it can use machine learning to train against billions and billions of miles of driving. Tesla has an entire fleet whereas SpaceX doesn't have that. So this training can make LiDAR obsolete using the radar combined with the cameras. If the car artificial intelligence can estimate the distance of objects, then LiDAR becomes pretty pointless. And you also don't need to be super exact or super precise with the exact distances while you're driving. You and I can drive a car without knowing the exact distance of every object around you. Here is a list of all the other sensors that a Tesla car already has, including 8 different cameras and ultrasonics that can measure distance up to 8 meters away from the car. And of course, with long-range radar in front of the car that can tell the distance in front of the car. So LiDAR is essentially duplicating all of this functionality for not much more benefit. And that's why Tesla doesn't need LiDAR despite the backlash from the industry, whereas LiDAR was a great decision for SpaceX at the time in 2009 to guide its Dragon vehicle. Hope you enjoyed this video. Please subscribe to our YouTube channel. We would really appreciate your support in helping us grow our channel. Remember to hit that like button, and thanks so much for watching.